Which means, again, I'm going to move back from the advent of code now that day 5 is done, and I'm going to move back to the compiler project. I have broken one rule of this project. Yesterday evening, after the stream, of course, I'm always happy to do code reviews and stuff, and like Haskell is my favorite language. I'm always happy to talk about it. So I've broken a rule of this project. Yesterday evening, after finishing the stream, I made one commit off stream. So some of the code of this project was written off stream for the first time since the beginning of the project. It was a fairly short commit. Actually, if I just scroll this, it's visible on stream. It was not this one, the one above, this one. I just made a very, very small change to the way names are rendered in the debug view. And I've made, I think, a change to some of the colors as well. Yeah, I've made a change to the CSS, and I've made a change to how the names are rendered. It's one commit I have made on the code outside of the stream. The big change is now this. If I go back there and I have this test file that contains a bunch of declarations in like this pseudo Rust that we are parsing, and I run the compiler on this that for now only do the analysis, the debug file that is generated uses a much, much better scheme. It looks like this now with better colors and better everything. And also now the names of the types are mangled to just be that. Oh, what is it? Oh no, it's broken. What is broken? Oh, no, there we go. Oh, but the names, since I've replaced the names, this is broken now. That's annoying. Oh, something is... Why is... What's happening? My computer just froze. What's happening? Why is Firefox using 12 gigs of what? Surely this debug view cannot be the culprit. No, it wasn't. Something is deeply wrong. Oh, no, there we go. I have a GHC that's taking 100% of the CPU now. What am I compiling right now? I don't have a compilation running there. I don't have a compilation running here. What GHCs? I'm just gonna... Oh, it's been running for 25 hours? What's happening there? Just gonna kill it. It's still there. Okay. There we go. It's gone. Very weird. Okay. But anyway, the point of the... yeah, exactly. Crossplate Chrome for a moment. I don't know what was happening. But yeah, this debug page that I was working on, I've made a few changes where now the types are rendered a bit better. And we still have the thing where the highlighting works thanks to a contribution from someone yesterday. So I can see that this resolved version of this concrete function, which calls the generic one function with the type parameter char, is resolved to be this particular symbol with the mangled name that contains the type information, and it's been instantiated for characters. So we have a much better view of the debugging thing now. So that was the work that went yesterday, and I've made one commit outside of the stream just to change the appearance, but no code commit on the project otherwise. This evening, since now I have time for. Oh, I hadn't seen. Thank you so much for subscribing. You don't have to, but I really appreciate it. Next here on the project, I think I'm at the point where I'm almost at feature parity with the code pre-refactor. This is a cleanup I really want to do, but it probably requires having more tests before I do it. This would be purely a like I clean the code and add comments, something that I'll do probably on a smaller stream if I do like a camera-less stream at the end of the month or something like this. So I think this evening, let's tackle the last thing that is missing from the pre-refactor time, which is the lowering into IR. So at the moment, our compiler has lexing parsing, most of the analysis, as in name resolving, type checking. We have broken the lowering into IR, which we need to fix this evening. Afterwards, we'll need to do the code generation, which is not done, but then linking assembly is done. So we are only missing lowering into IR and code generation. Only, with big air quotes. So let's go back to the IR, and let's see how it's defined. Is everything back to normal in the meantime? Everything seems to be back to normal. As far as having too many Firefox tabs goes. So I think a lot of this is going to change, because a lot of this definition, as indicated by this very helpful comment, is from before we changed everything about the way data is represented in the output of the analysis phase. So a lot of this might just not need to exist in the same way anymore. I think function and block is perfectly fine. However, IR being a hash map of name to function is, I think, completely wrong. Because I think the IR will be on a per module basis. But actually, is that true? Like, do I even want to have this type of like, oh, I have a collection of things at the IR, or do I just want to have somehow another way? No, I think I want to have it per module because I want to do incremental compilation. So I want to be able to generate the IR and then do the code generation for one module at a time to store the bytecode version of all of the symbols. So no, I think I will want to have an IR representation that is one compilation unit. I think, however, only having the symbols is not necessarily correct. It is correct for our purpose. If we ever do the export into LLVMIR, this will not be enough, but we can use the interface. So no, okay, I'm starting to think this is good enough for our purpose. So a function has a label that is where it starts, and then a bunch of labels and blocks. And the block is... Yes, okay, I remember all of this. I haven't touched any of this in, at this point, a few months. So I have to go over this and remember how it works. The big thing I need to change is this type thing. It doesn't work. It doesn't work because the struct type, like it's a type tree, of course, but it contains a non-empty list of the types of the fields, which prevent self-recursive or mutually recursive structs because it would need to be fully inlined, which is not possible. So this doesn't work. Since at the moment I don't have arrays in the language, mutually recursive structs are not something that is possible yet, but at some point it will be. So I want to support that. So this type has to go. However, since last time we worked on this, we now have a proper type tree here that does a proper indirection for structs and everything. So I think we can use that. However, the problem with using this is that for structs, we are basically keeping like an index into something else, basically. And that might not be a kind of thing that we can keep doing at this point. So that reminds me that maybe I will want to do instantiations of structs as well, and like having a hash map from named struct to the so that I don't have to do type substitution all the time. I might want to do that actually. Yeah. So if I do that, that means that in the interface of a module after the analysis, here in my definition cache, I will probably want. I'll probably want to add a struct cache as well for the structs that have been instantiated. Yeah, I might want to do that. So this would be a struct cache. I'm gonna create one more alias for this, where a struct cache will be from name to validated struct info, I suppose. And validated struct info. I'm looking at the wrong validated. I want this one. I think that's correct. Except here I will want that to be concrete. So this will be validated struct info with a concrete functor. So that means we need to fix a few things. The analysis needs to give us here interface. We just said it was struct will be something. So this needs to be created somewhere. And I think this will be done as part of the validation there. Where can I encounter a struct like this? I suppose anytime I resolve a concrete type that happens to be a struct, I can put that. So this would be probably here module struct. One more thing coming from the validate monad. So validate, and I want the monad within the validation phase. It's this one. So our state will be keeping one more thing. We will be keeping a struct cache of the structs that have been instantiated as part of this. Does that mean I need to keep track of... Does that mean I need to keep track of the struct cache coming from other... Yeah, I need to. So that's another struct cache. Which means here this will take the struct cache as well. That being said, I was gonna say this is only needed for the export to LLVMIR. No, this is also needed for us so that we can do a lookup of like, oh, I know what concrete version of this struct this is. I need to go look up what the fields are. And since I can't inline them in the type representation in the AR, I will need to have some kind of cache to do the indirection. That's what this is. And I might as well construct it while doing the validation because I will be checking, yeah, okay, I think this makes sense. So this is a big departure, but that's fine. That's what working on this project is sometimes. And I will therefore need to give it here the struct cache coming from here. Which means run validate now also takes... the validate info takes... it's the validate function. Here that will also take the struct cache and returns a struct cache and takes the struct cache and creates vi structs with the struct cache, and then does a run validate with this, and will return one last thing, which will be the vs struct. Okay. We are missing one thing, I believe. Here I've added one more thing, and I need to add it here. Which is going to be initialized at first as an empty hash map. Okay. Oh, let me just quickly answer this thing. There we go. Next. So we now have changed validate to contain an output, which is a cache of structs, but also take as input the cache of structs coming from other modules. And this is a cache that is indexed by the unique name that uniquely identifies anything across the program. Nothing else needs to change. But that means that whenever I resolve a concrete struct, so a struct whose parameters are known, if I look at validated, that means every time I create a concrete type that creates a struct type with a struct type info for a concrete type, struct type info, because that base name plus concrete type, that is how we create a name. And that means every time I do that, I can just it's almost tempting to change this to always be a name in the case where, but if I change the shape of this in the case of concrete types, that's going to become a nightmare. Okay. So that just means if I go to types, so either invalidate concrete type, which goes validate struct type. Yeah, so every time I do this and I create a struct type info, in which places do I create a struct type info? And that's all invalidated. That's not where I actually create it. Pretty printing is only doing pretty printing. So it is... I do it once in expression. Here. When I encounter a struct expression, that makes sense. So I'm constructing a struct in the context of some expression which is always concrete. Therefore, that is a concrete type. So this would be, yeah, so I need to register it there, okay. And otherwise, it is purely in types. Struct type info. Here I create it when I'm trying to validate a type in a function or something, and I end up realizing, oh, this thing is a struct, here is the type info, okay? That's for partial type. In this case, I don't need to do it. Parameterized type, I don't need to do it. Concretized type is not a place where I would... actually, is it? I think it would be. I think every single time I'm creating a struct type info that is concrete, I need to register it. So that would be one more case of this. Validate concrete type. Yeah, that's the one we've already known. So okay, that's everything, I think. Okay, perfect. So let's do that. Do I want to do this as part of... Where do I want to put this function? Some of it will be... I think I'm going to put it in validate. No, I don't think I want to do that. I guess I can introduce at the very least a struct name function. Wait, what did I... No, it is... Wait. So my interface, I have the struct info. So it's not necessarily always when I... So when I have the struct type info, I have the key, but I will need to then retrieve the corresponding struct info to put it in the cache. So that's not trivial, but first we can start with this. If I have a struct type info, which is for a concrete struct in which all the types are known, I can do a maybe name, like so. Well, not like so, actually, at all. Because a struct type info is a base name and then a type tree. So let's go struct type info. Hello, how are you? This will be a name created with the struct base name. And because a name that uniquely identifies something is a base name plus a list of arguments. Yeah, I know, right? And this would then be, I have a bunch of concrete types here that I can transform using this. This will be into traverse type name of the struct type params. There we go. And I can remove all of this. So that's how I create the key of my struct cache whenever I discover a new concrete struct in my code. Next, I will need to do, whenever that happens, I might have in some places, if we go back to, in the case of the expression. Okay, so here I have both the type info and the actual info, and it's the concrete. So I have both the key and the value. That makes creating the cache trivial. That's great. In the case of type, here, I am writing in Haskell a compiler for not Haskell. Our language we're trying to compile is a subset of Rust. It looks like Rust, but it's a much, much simpler version of Rust. So it has like functions and it has like type arguments and it has like a bunch of things that you would expect in Rust, but it doesn't have dynamic memory allocation because it doesn't have a heap. It doesn't have traits. It doesn't have like a lot of things. It's a small subset of Rust. this project is a silly project, but I'm taking it as seriously as I would a real compiler. So it has the complicated architecture of like having a proper lexer parser. I'm using Alex and Happy, which are the tools that GHC uses for its lexing and parsing and so on. Our IR is is similar to the LLVMIR, and I'm planning at some point to do an export from our IR to the LLVMIR. But the reason why our language is such a small subset of Rust is because what we are targeting is not an actual binary. I'm not trying to generate an actual program with this source code. I'm transpiling, in a sense, to an esoteric language called Piètre. And Piètre is a very peculiar esoteric language in which the source code is an image. This is a valid Piètre program that prints two characters and then outputs. It does basically nothing else. The way it structures is basically like each group of pixels like this represents like a thing of information, and each transition from one group of pixels to another encodes one of 17 or 18 basic instructions. There is no heap, there's no memory allocation, it's purely a stack-based language. And the idea, as you can see, is like every function is one vertical block like this, with labels being like the entries into the function, like here or like here. And the linking of a Piètre program will be taking all of those functions and resolving where the addresses need to go, and then doing the assembly by creating an image of all of them. So that's why I have this small subset of Rust that I'm restricted to. It's because I need to be able to compile to something that doesn't have a heap, doesn't have anything like that. Traits could be added to this language, prevented that, like as long as they are all resolved at compile time. But I decided to go for like a much simpler approach to the language because this project is already big enough. So yeah, that's the project. The backend is already done, the frontend is already done, the lowering into AR is the part I need to rewrite, and then the code generation is the only part that's missing. And then there's a lot of cleanup that's missing, there's very little documentation, there's not enough tests yet, there's a lot of work that needs to go into before this is like actually ready. And of course, all the incremental compilation, the structure is there, but that's not actually written in yet. So there is still a lot of work before we are at the point where we can actually use this properly. What I'm doing at the moment is, so I have this old, before I did a big refactor over the last 2 months of the way the analysis works, but I have this old version of how the IR is structured, which is again somewhat compatible with the LLVMAR. However, some of the choices I had made at the time when I wrote this were wrong, including the fact that here the representation of type information in VIR inlines all of the structs. So the structs list the types of its fields. The problem being that there could be cycles in this, because a struct A could have a list of values of type struct B, and the struct B could have a list of values of type struct A. And if I'm trying to do this, then I will have list of B here, and then B contains list of A, and this is an infinite tree if I don't like remove the cycles. The easiest way to remove the cycle is to use a key. So if I have a struct, instead of listing the types, I'm saying it's this struct with this name, and I keep a cache of, from a struct name, the field information, so I can do this kind of lookup and do the graph afterwards. But if I want to do that, then I need to have a cache of my concrete structs, so structs where the type arguments are known, and I don't have that yet. So this evening, I am adding that to my analysis phase. So what I'm trying to do at the moment is every single place where I find a type of a struct and I realize, oh, this is the type, a type of a struct, and now I know all of its type arguments, I have a concrete struct type, I can therefore put it in a cache that will be used in conjunction with this to do type handling in the lowering into AR. So in the case here where I find a struct expression, it's perfect. I have the type information here, I have the resolved struct information here, so I have everything I need. However, in types, this is where I will not have it. But I think here for that's a problem. The problem here being this thing happens when I'm validating the types before actually going through. So if so obtaining the struct info to put it into the cache would mean breaking the cycle breaking thing I have here. That is a problem. Well, it depends. I mean, I've been writing variants of like Lexer, parser, compiler for years, including professionally at some point. I love that. A previous project of mine that I use for the advent of code sometimes is a much simpler thing called brainfuck stack, which basically provides me with very basic functions in brainfuck and generates brainfuck for me, which makes writing brainfuck code a tiny bit easier. It was like a tenth of the size of this project. So what I'm trying to figure out here is, can I actually do this cache of functions, or do I have a problem where I might not be able to do it every time I create a struct type? Maybe I'm not able to do it at that stage during the analysis phase, and instead it means I need to do it when I'm doing the lowering into AR. Which is a tiny bit annoying. It means every time. Let me think about this for a second. Let me think about this for a second. The problem is this. When I do the validation phase, I start by iterating over all of the definitions. I have used Haskell both professionally and for fun for a decade at this point. I did use it professionally for 3 years from 2020 to 2023. I miss it dearly. I wish I'm looking for a new job at the moment. I really hope I can find something in Haskell because it's the one I enjoy the most. The problem is jobs in Haskell, they are very few and far between, and the few that exist tend to be cryptocurrency and blockchain stuff to this day, which really sucks. So yeah, whenever it's like Haskell in a job description, I apply quickly because worth a try. So here what I do is I iterate over the definitions at the top level. I don't do function instantiation at that point because I need first to make sure that my cache is populated with all the type information. I suppose then I could register the structs only in the context of function instantiation, because in that context I know that the information will be in the cache. Because in the definition cache that I have as part of the validation, that definition cache is a validated definition cache. Yep. And that validated definition where are you? Definition. There we are. For a struct is the struct info. So that means I don't want to do this kind of cache thing. I don't want to do this kind of cache thing at the when I'm validating a type declaration, I need to do it. I can do it in the case of expressions. That's convenient. And I suppose when I do function instantiation is where I can also oh, that's tricky. Okay. I suppose that if I can a function return a struct without constructing that struct? Yes, with panics. So I don't have the guarantee that any struct definition will be accompanied by a struct construction. So I cannot only rely on the struct expression to guarantee the construction of the cache. There is another option, which is I don't bother doing this at all because it's extremely complicated and error prone. And instead, I just use a definition cache whenever I need to find a struct definition afterwards. The only downside of this will be that I would have to check, oh, is this base name actually a struct? And then re-implement type substitution there again, which feels not needed. Let's look at function instantiation again. Is there a way to solve this? Here's an example of I will encounter a concrete struct type, but I will not have the information at hand, a function call. If I call a function that returns a struct, this function might be a generic function, so I will do parameter type substitution to get the actual concrete function so I can link against a uniquely instantiated symbol. But the return type that I will obtain somewhere in here will be obtained by doing a reify type there. And that might not be, I might not be able to obtain. I might obtain the struct there, but I will not have the struct information. Wait. The only issue, the only thing that prevents me from doing a lookup in my definitions for a struct is this validation of structs here, actually. And here I only do a validate parameterized type. And validate parameterized type doesn't do any kind of... Yep, okay, so I think it's fine actually. Okay, so let's do that. This is going to be a tiny bit error prone. That's going to be something we're going to want to test pretty strongly afterwards. So here, this is what I'm looking at, struct type info. So this is the case where I create an expression of a struct type by creating a struct. So I will look at the type info and the struct info, because I will need to know exactly what that struct is to be able to validate it, which means at this point, I have the struct type and the struct info, I am able to create my cache. So my vi struct, which is the cache I keep as part of this thing, can be modified to insert given a validated struct type key, a validated struct info value. Okay. This will need a comment. This is really error prone. For a field access expression, do I need to do that or is it not required? Validate field function access, that's the one. So here I also create a validate struct info given a struct type info that is concrete, I believe. Because that's the validated expression. So yes, it is. Perfect. So that's another case where I will know of a concrete struct type. I'm trying to think of, is this required in a sense of like, since a field access means the left-hand side is a struct, therefore I will have already found what the thing on the left is, therefore I probably don't need to put it in the cache. There is, I was gonna say there's an exception to this rule if I have a panic on the left-hand side. No, I think in this case, if the left-hand side has a concrete struct type, it means we have already resolved a concrete struct type, meaning we already have put the thing in the cache. Therefore, I don't think we need to do anything here. So that means the only other place we need to do stuff would be when validating a concrete type and when reifying a type. So if I look for type struct type info there again, this would be here when validating a concrete type. Not for partial types, not for parameterized types, not here, but in concretized type for sure, and probably in reify type as well. Especially in reify type, I think. Okay. So that means I will need a helper function for this, which is going to be, I need to put the struct in the cache. So that's gonna be a new function in this. Cache struct info, which given a struct type info, which is our key, which is going to be a concrete version of this, will perform an action in validate. And that's going to be about it. So we will have just the struct type info, I suppose. what do we do in this? First, where are you validated? There you are. So first, I will want to create the key, which will be... Oh, I didn't do that in the other... Okay, so I need to do that afterwards as well. I will need to create the key, which will be obtained with the struct name. There we go. So this is going to be the unique name of this particular struct with its instantiation will be the struct name of the struct type info. And if that fails on nothing, I think for now this is an internal compiler error, because the only case where that fails is when we've tried to instantiate a function with a struct with a function type, which are not supported in the syntax of the language yet. So I think that's purely an internal compiler error at this point. Okay. And in fact, this can... Well, it's fine to do it like this. And after that, we can do... Oh, I need to be very careful. I need to be very careful. Because if I have a struct A that points to a struct B and a struct B that points to a struct A, I get the struct A here, so I try to put it in the cache. But to do this, I need to compute the exact value given the concrete type info. And therefore, I do a fetch. I could end up with an infinite recursion here. I need to be very careful. So I need to do this if it's not in the cache already. So I need to do a lookup. This is, I thank you for saying this. This is one of my goals with this project. There is no code written outside of the stream, and I'm trying, even though in the current state of the project I am far from meeting my goal, I want this project to be readable. So I'm trying to be careful with naming things. I avoid single letter names as much as I can. I try to have like a very clear structure for the files. The code is at the moment too complex to be properly readable, but that is my goal. I want this project to be approachable for someone who has passing familiarity with Haskell. That doesn't mean I'm shying away from complexity. There are some complicated things done in this project in terms of like language Haskell shenanigans, but I'm trying to keep it readable as much as I can. So here, what I want to do is I want to do a lookup in my structs. So I want to do a uses to apply this lens into my state. And what I want to do is a lookup of the name. So this will give me the information that is already in the cache for this struct. And I only care to do something about it when it is nothing. So I can directly do a case of this result. If I found an existing value, then there's nothing to do. If there is nothing, then there is nothing for this in the cache. Therefore, we should be doing the instantiation. And that means, what does that mean, doing the instantiation? That means doing a lookup. Where's my context There we go. I need to do a retrieve struct, I think, or lookup struct. Nope, that's what I want. Perfect. So I will obtain the parameterize struct info. There we go. Which will be obtained by doing a retrieve struct using the struct base name of the struct type info. So now we have the struct info, which is this. Where are you, struct info? This thing. But the problem is here I have parameterized type based on this. So I will need to do something I already do in a few places. Would I want to actually have this function be the function that do I want this to be the function that does reification and cache? Which instead gives me the actual struct info for a concrete type, in which case this becomes, I return the value that was given to me by my lookup, and if it gave me nothing, I do something else, which is doing this lookup and then doing the replacement of the thing. If I go look at expression and I look at my struct expression, there we go, validate struct expression. This one, where I already do this work anyway. That's not what I want to do, because here what I'm looking for is... There we go. So I need the mapping. So, okay, so then if I want to move this here, this function would need the mapping, which is... What is the argument to reify type? It is a hash map from this. That's another thing I want to change. Okay, perfect. So this would be the map of the type parameters. And so what we do here is basically that. So I'm going to move here. There we go. We retrieve the struct. We do the mapping, and then at the end we have a concrete struct info and we have the name. And in this case, we can, since there was no... I have this struct in the name, I can do a... I modify in my state my struct to do an insert of the name and this validated struct info. And I return the validated struct info, which means here in this piece of the code, this becomes validated struct info is reify and cache the struct info based on the struct type info that I just created, the validated struct type, and the final mapping. Because in this function, what we do is we have an expression of the form like this, something like this, that creates a struct. But if S is a generic struct, something like this, then we need to do type inference to figure out what T1 and T2 are. So here we will know that this is a number, therefore T1 is a number, T2 is a number. And as a result, we can create this struct info in which this becomes, instead of being this struct S where X is T1 and Y is T2, the reified version becomes basically ST1, T2, a instantiated version of the struct where X is of type, well, in this case it would be int and int, I suppose, where X is an int and Y is an int. And that's the version we want to cache, because we will want to have a dedicated thing per struct like this to avoid having to do that work of reification moving forward. So this function creates the struct info, perfect. And now in every place where I create a struct type info here, I can call this function as long as I have a mapping, which I should have, or I should be able to create. So reify and cache struct info takes the type info concrete and okay. This is a problem. If I go here, do I have the base name? I do have the base name. Okay. So here I get the type parameters of the struct, and I have the actual parameters that have been provided. I validate that the count is correct, so there is the same amount. Therefore, the parameter mapping will be a map from list of zip the expected parameters with the actual parameters. The struct type info will be this. Oh, I'm just going to move this instead. And the only thing is, here I will need to reify and cache the struct info, even though I don't actually need it at this point. And I will need to give this the struct type info that I have just created and the parameter mapping. There we go. And now to check the other places where we create a struct type info. That's for a partial type, I don't care. That's for a parameterized type, I don't care. So I guess the only other ones I care about. I don't think I care about concretized type. Partial types are only used. It probably doesn't hurt to do it. The problem is the parameter mapping. The problem is the parameter mapping. I kind of, yeah, okay. I'm trying to see also while doing this how I can avoid doing unnecessary work. So since here I'm gonna be retrieving the struct anyway, which is gonna be like the struct info, which is gonna be the parameterized one, I will have the struct params, which means instead of getting the mapping here, I could probably just get a list of concrete type and create the mapping here. Which is gonna be a map from list of zip something about the struct params with the actual params given here. And this is, for now, until this is changed, struct base name added at the beginning, made into a tuple with the struct params. That's the mapping. So that means refi and cache struct info. Here, I'm not giving the actual param mapping, which I therefore might not need. So I might remove the expected. I guess I could move this. I can move all of this into. Yeah, I can move this validation as well into it. So I can remove this entirely. I can move this validation there. Because the expected params are the struct params. And the base name is the struct. That struct base name of struct base name I think is wrong. That's, yeah, I'm just gonna deconstruct the struct type info here. Which means this is just struct base name. There we go, and that's struct base name here. Okay. And I did add the validate params count, so that's fine. So here I can remove the parameter mapping. All of this goes away. The only thing we have left is this. Perfect. Now, when I do a validate a refi type and a concretize type, this is where I'm going to need to do the same thing. Oh, I need to be careful. Yes, okay. So here I'm trying to concretize a struct type. So I have my struct type info, which is this, which is what I want to return out of this function. But I can do a refi and cache struct info that takes the concrete type parameters and the struct type info. Although I'm fairly certain it's the other way around. It is the other way around. Wait. So the order here is wrong. Okay. So let's go back here. Perfect. Let's check that the order of arguments is correct up there as well. Yep, it is. And we can try the same thing here in refi type. Ah, that's... Oh, that's annoying. I can't do that. Refi type exists for both concrete... Ha. Do I ever use this function? Do I ever use this function to refi something not into a concrete type? I don't think so. I don't think I ever use it to make a partial type out of this. So I'm gonna decide that this is not for all f, but in fact it is for a concrete type and returns a concrete type. So basically, yeah, I think that's gonna be it. Which means all of the at f here go away, or at least are replaced that by at concrete functor. And here refi struct type will be struct type info is this, and that's the concrete one. And then we can do a refi and cache. Oh wait, do I have the type parameters there? Wait, am I an idiot? I think I might be an idiot. The struct type info contains the list of concrete types. Okay. So I don't need this second argument to refi cache and okay. And then I return the pure struct type info. I don't need this second argument. That is the struct type params. Which means here struct type params. So I don't need that. Perfect. Which means when I go back to this... Oh, where's the mapping coming from? Well, I don't need it anyway, so that's fine. Okay. Okay, so that should be all good. And let's just check on the expression version. Wait. Yeah, I don't need this final mapping anymore because I can just create it. Okay. Okay, so that should be all for this change. Let's try to compile this and see if anything is wrong in this. I at this point I have a very small test suite of for the compiler, but that doesn't contain at the moment any tests for the analysis phase I'm currently developing. So a lot of it is I have a very ugly test file, which is this thing, which is written in the language I'm trying to compile. And what I do is the main I have for my compiler at the moment doesn't do incremental compilation or anything like this. It just prints all of the information we have tried to compile, we have extracted out of the module that we're compiling. And since yesterday, I also have a debug page. Where is it? There we go. That displays like a nice HTML rendering of the information extracted out of a module. So I can check that, like, oh, when I compiled this function, I did resolve that. Why was this argument? I did resolve when I called this bar2 thing that it was actually whatever this actually links to. Like this generic 2 ends up being this one. Like I can check this kind of stuff to verify that it has been validated. This doesn't replace a good test suite. I will want to have a good test suite at some point. But this is for now until I have actually finished this phase enough that I can actually write tests that I'm confident in. This is the kind of manual testing I've been relying on. Here, struct info non-scope, I suppose. It could be either resolved or validated. In this case, this is a validated struct info. This is just the struct name I have. Wait, no, I'm wrong. Ah, struct name is an overloaded thing. I have more than one thing called struct name. So let's go back to this and change the name of this function to struct type name. Which means I can go back here to types, and this is now struct type name. Oops. And this is indeed also a validated struct info. Refi type to type argument f. What's wrong here? What has changed? This is not a function I have changed right now. So why is it different now? What have I broken? Is it because I have changed? Oh, it's because I have changed refi type. I have changed refi type, and this is a place where I was using it with a type argument. But do I ever have? I think this was also unnecessarily generic. I don't think I have a need to do this for a partial type. Ah, no, I do it here. So I do have a need for... Ah, this is frustrating. Okay, so I've made a mistake. Okay, I'm trying to think. Doing this the way I have started doing it now requires changing something pretty fundamental about the way type reification is done. And most importantly, and I think that's the part that bothers me, it really requires going like, yeah, I don't like this at all. Because another option is to not do this at the time where I validate those struct infos like this, and instead, when I do the lowering into IR, every time I encounter a struct type, and it was a generic struct, and now I have the version, I do this kind of like lookup registration kind of thing. The upside of doing it while lowering into IR is that the code becomes a ton simpler and a lot less error prone. The downside becomes that some of the reification code, which is part at the moment of the validation phase, bleeds into the lowering phase, which I am not a huge fan of. But it probably will be simpler than this. It will be simpler than this, and maybe I can rewrite a simpler version. Okay, so I'm gonna give up on this particular change I've been trying to make. I think it's incorrect. I think it is incorrect, which is a bit frustrating, but it's a negative result, but negative result is still a result. Trying to do this at this stage will prove to be unnecessarily complicated. So let's not do that here. Okay. I can keep this actually. This will be useful whenever I do this kind of operation down the line. But let's remove those changes, sadly. It's a shame, but that was not the right approach. Okay, so instead we go back. Oh, actually, let me check that this compiles. It does, perfect. So let's go back to the IR. And I think the thing here is this type is basically optional at this point. I think it's obsolete at this point, to be very precise, because I think now the new validated type that we have here, the concrete version, will be exactly what we need. The only difference, no, this has a function type as well, which contains a function type info, and the function type info is, yeah, for a concrete type will be list of the arguments and the return type. Yeah, that is exactly what we need. I think I'm gonna change this by removing this type out of our old IR. So now our IR for a function is what label do we start with, and then a list of blocks, which is the name of a label and a block of instructions. And that's the parents of the given block, the arguments, because I am using a particular research paper for my lowering into AR, this one, a simple and efficient construction of static single assignment form, but I make one change to it. This one uses phi functions as a way to resolve ambiguities in assignments. Well, ambiguities. When a variable can come from more than one parent block, and instead of using phi functions, which is a pretty common approach that some of those papers do, I use a newer approach called block arguments, where basically every block has arguments as input, and the parent blocks provide an argument that then will be used within the block here. Then I have the instructions, and I have a terminator, which is a thing that ends a block, and the terminator is jump to another target, which is a label with a bunch of arguments, branch to one of those two based on the value of a register, or return, or panic. The thing that's temporary here is just the show of a register. I will want to use the stock show at some point, but for debugging purposes, I was using this instance of show where I was putting like type information in the register name, which made some things easier. Okay, so everything else remains the same, I think. Those are my basic instructions. I think those will remain the same at the moment. What will change, so type goes away. What I need to do now is to go back to this file that used to exist before and no longer exists, and we need to make it work again. I wonder what's gonna happen if I try to compile it in place. I wonder if I should... Do I want to import here and export a type where I used to have a type before? My type is actually the validated concrete type. And that way it's exported out of this module, which means now if I do IR type here, it is pointing to the same and I don't have to change the code. Oh, I seem to have a lowering monad. Let's have a look there. I will probably want to change this. The M suffix is not how I've named my other monads in the project. And I've named most of them based on the phase. I think lowering is fine then. Oh, interesting. I didn't make lenses for this thing. So wait, registers have types? Yep, that makes sense. Also, this is going to be broken, probably. Or maybe I'm just gonna do that for now. Which is not great, but still, for debugging purposes, is perfectly fine. So I'm going to assume that most of this remains the same at the moment, except lowering M becomes lowering. I remember some of that logic. That's, yeah, one big thing I want to do at some point, and maybe this is going to be one of those streams where I do some work like camera of like off day stream. I really need to comment this project because I haven't read this code in 2 months, and I remember the logic of it, but the details are a bit hazy for sure, and that's not great. So here, what has changed? I think everything has changed. I need to be careful. Is it called function archetype now? Has this changed since last time this was written? No, it's still called function archetype. Okay. Force type. What are you? Force type. You're something that takes a path info resolved and gives me a lowering IR type. That is no longer a thing that exists because we already have IR type instead of types, so this function just goes away entirely. Yeah, path info resolved, that's also a thing that just goes away entirely, including 3 internal compiler errors. That's great. So the whole point of the refactor I've done over the last 2 months was changing the output of the analysis phase to make some of the checks that we perform as part of it reflected in the type system, so I could remove a lot of the internal compiler errors that are part of this stuff. Why are you unimplemented? Why are you written as an F map rather than just that? Okay, so for each argument, I make a register. Makes sense. This should be the same. Seal block, that shouldn't have changed. Process block really looks like... Why have I written this as being a case switch on a list rather than being a fold of some kind? Oh, because I want to be able to short circuit when something is not reachable to unblock the panic and emit a warning. Okay. Ah, there we go. This was a change I've made as well. I used to detect whether a continue statement or break statement or something like this would appear outside of a loop, which means here at this point, since I'm doing the control flow analysis, I would check that again and end up being like, well, if it happens, like I know I'm in a loop since I've already checked. Now I've removed the check, so now this is no longer, this to do is done. report error instead remove analysis phase diagnostic. So now instead of being this will be some fatal thing. And if I look at my diagnosis, error not in a loop or something. Error continue not in loop, error break not in loop. There we go. Oh, but that means I need also to do lowering. Yeah, there we go. That means my lowering monad needs to have diagnosis capability, which I think it doesn't at the moment. Which means it will need to have diagnosis here, and this will be a diagnosis T on top of everything else. And that means that run lowering might fail, and therefore it will need to be done in the context of a monad diagnosis, which is a coding context, and this becomes something in MA, and this becomes as a result a subsume here, which will take the result of run diagnosis T here and put it back into this one, which means run lowering here. Where are you at the top? This becomes not an F map but a traverse, because this is now in some kind of monad diagnosis M, which is the coding context. Because this is now also in some monad M, whatever it is that happens to have the capability to store diagnostics. And everything else remains the same. There we go. Process statement shouldn't have changed, I think, beyond what we have already done. There's a few to-dos here and there. Okay, so here that means I will need validated as AST, perfect. I can probably do, if I ever have AST dot a bunch of not space characters followed by resolved. That is just actually the first part. The resolves can go away. Okay. Okay, all of this looks good. Aha, so here is where everything has changed, because this was using the old expression type, and now we no longer have the old expression type, we have the new expression type. In fact, this is not a typed expression, this is a typed AST expression. There we go. When do we return nothing here? In which cases do we have something that gives us not a register? I guess if we have something that gives us unit. Yep, assignment gives us nothing. Okay. So we can compare. That's not what I meant to do. I meant to do that. I meant to go to validated here. I meant to look at the expression type here. Like one big change, for instance, there is no longer path expression. This was a nightmare, and now they just no longer exist. So I just not have to worry about it anymore, which is nice. Aha. This is also obsolete. This was a fact that like my assignment expression, the left-hand side was an arbitrary expression. Now it is an L value expression. So I no longer have the problem of a sign might not be to something that can be assigned to. So that's perfect. Okay, so the Boolean literal hasn't changed, so I'm keeping those the same. Int negation hasn't changed. I'm keeping it the same. Addition, subtraction, multiplication, division, modulo, exponentiation, equality, difference. All of those are the same. I have nothing to change here. Boolean AND is very complicated, and Boolean OR is very complicated, but they haven't changed. Force type is no longer something that needs to exist, because now that's just the type. I can actually go search for force type, or any use of type, actually. Yeah, here force type is no longer required. This is purely make register of the function arg. Wait. Yep, function arg type. There we go. Typed expression. I'm going to do replaced. Replace, that is now typed AST expression. This is the typed value. Okay, so cast has changed as well. Assignment is no longer a force expression. This is going to be force an L value expression. Or I've called process when it can give me a maybe register, force when it must give me. I'll see. For now, I'm going to create process. We'll see what happens. Assign register, pure nothing. Perfect. Compound assign. Force type, no longer a thing that is required. Call expression no longer exists. Now I have either a function name, a function call expression, or a variable call expression. Oh, but I do have a function name expression I need to handle, I think. So this would be a function call expression with the name, function name, and call arguments. The function type info on the arguments. So here the retrieve function info is not required anymore because I have the function type info with me. And this function type info has everything I could want. I don't think I need translate type. I don't think that's a thing that needs to exist anymore. fun return, yep. So if I do open this as that's just fun return, there we go. Oh, I think this function value thing was the result of the result of doing a resolve function info in the old version of the code, where I had to decide where is this function coming from. Now I don't have to do that because I have invoke. Yep, there we go. So in the function call expression, I know for a fact that I am invoking a named function that will need to be linked against. So it's that. Which means I need to duplicate this, but with the invoke R, to calling a function that is stored in a register that rather than calling something that is linked. And that is not a function call expression, that is a function, a variable call expression. Which has instead the identifier, the variable name, I suppose, and that's the variable name here, I think, if I look at my IR. That's the register. So I need, given an identifier, to find the corresponding register. How do I find the register associated with a given name? Resolve name, there we go. So resolve name is what I want. In my variable call expression, I will get the register in which that function is stored by fun register will be a resolve name of the variable name, and that gives me the function register. Perfect. Force type no longer exists. Those are not implemented, and I'm missing one. I am missing one new expression that didn't exist before. I am missing the function name expression. I am missing what used to be the path expression. It has been replaced by a few others since. It's getting late. I should probably stop soon. I am starting to be tired. Local variable expression, reference argument expression, and and function name expression. Those are the three I'm missing at the moment, and I kind of want them to be able to do things. So let's add them. I am missing this one. And this one. I think this one is purely... This one is not about adding any instruction to the current block. There's no need to do that. I think this is purely... This is purely a resolved name of the var name and nothing else. If I look at the code I have removed, and I look at path, where are you? Path expression, there we go. Resolve path. Oh, I have kept resolve path. So I can just go look at it. Wait, no, it doesn't exist anymore. Am I looking at the... No. Because I can't type. There we go. There it is. Okay, so that was exactly that. This was... Ah, but I need to type. I need to type information for resolved name. Wait, why would I happen an instruction if the thing was pointing to a top-level declaration? Was I assuming that this was a constant? That makes no sense. Oh, maybe it was just a... That's the handling of functions. Okay. This all goes away. So resolve name here requires the type. So I need to know the function type. And that is purely... this function type info, and here this is a function type. Oh, well, actually, I don't need to do that. This is... Wait, no, I need to do that. Ah, that's annoying. The undo thing destroyed the layout. Okay, here I was gonna say this is just the type information that I have from the typed constructor, but no, because the typed constructor version for a function call will be the return type. So this is in fact a function type of the function type info. Okay, I could probably change this thing by using the typed information instead, but we'll see if I do that later. So this is going to be resolved variable name, and I suppose I can do the thing where let's do type info right there. Literally the same thing here. And I think if that's name, I probably need to assign this to a register, because there might not be a register for that value yet. So this is probably going to be target is making a register for this with the type of the variable. And then I will append an instruction, which will be an assign instruction. Let me check this assumption. This might not be true. It's an assign A. No, there we go. That's what it is. It's an assign A of that target of the function name. Okay. Excuse me. Seem to be doing some kind of allergic reaction. Great. I will probably stop soon because it's getting late and I am getting tired. Here this doesn't work. I'm gonna need to change this to be instead. This is a force L value expression instead. That's the other way around. The L value is on the left-hand side, as suggested by the L. So I suppose I need to check this then. I'm gonna keep it the same for now. Okay. What else am I missing? Assign register, I think, doesn't need to change. Except this is no longer X per value, this is typed value. Oh. Okay, so assign register is, I think, completely wrong. Yeah, okay, I think this function will have to go away, and I can use the L value expression here to give me to give me both the register from which to read. Yeah, this needs to all go away. This is all wrong. This is all from the old version of the code that is no longer relevant. Yeah, okay. So I will need force value expression to give me the register from which to read and the name of the thing in scope to which we have assigned something. Oh, this is more complicated than that. Because in the case of assigning to a field within a struct, the names in scope are not going to change. That's why here this is unimplemented. But I guess I can make this... How do I do that, actually? No, I suppose I can keep assign register. But instead, this is an L value expression. And here we will do a case of this L value expression. And an L value expression is definitely not the same thing. It can be, for instance, I think the only one I want to support for now is a local variable L expression. With a name, which removes yet another internal compiler error. Okay. Wait. Oh, instruction target. There we go. Okay. Oh, this is probably supposed to be where the value is coming from, and I've messed that up when doing the cleanup. Okay. Let me just check that quickly. Resolve path is gone, indeed. Yeah, that was value. Okay, and with this, I should be basically done. Retrieve function info is a thing of the past. God, look at this mess. That's one thing that just completely disappears. Retrieve field info. Where is that called? This is for a field access expression. Oh, but now a field access expression is completely different. Because in a field access expression and in a struct expression, I have the struct info right there. So I can probably change retrieve field info, which is field index, field type. Okay. Which if I have, yeah, I can change that completely. So this is gonna be instead the struct info. I don't need the struct info here. That's convenient. Um, well, no, I do actually. I don't. I assume the fields are correct. Okay, so a function what I've changed is the retrieve field info. That given a struct info and a field name will give me the field index and the field type. So this has a struct info, an AST struct info, and an identifier. And that should give me that indeed, but that should give me a type here immediately. I already have the struct info here. I don't need to do all of those lookups I had to do before. Why am I doing this recursion manually? I don't know. Aha, so substitute types is where I have to do... I don't need to do that. Yeah, why am I doing this recursion manually? This is just a find. Okay, that should be everything. Sorry. Maybe I don't need it qualified. Maybe as validated is enough. Okay, so maybe I want it qualified as AST then. But that means... AST, I probably want to change validated dot to AST dot if it shows up anywhere it doesn't. Okay. Where do I have int type then? Ah, yes, okay. It's getting late. Let's see if I can get this to compile. Because if I get it to compile, we can try printing the IR of some of the symbols of the functions we have been doing. So that would be pretty neat. Unit type and void type are missing. Oh, that might be a reason to keep a distinct type in the IR. I will not want to have unit and void as part of this. Okay, so that means I will need to not use the concrete type there. I will need to redo a version of it that is different for the IR. Okay. So that means I can simplify it a tiny bit compared to this version. Because as far as the IR is concerned, the type is one of those. But unit and void no longer exist because every register must have a type, or it must be a value that makes sense. Do I need to keep the enum type base name identifier thing? What did I have before in the IR type for enum and enum type is just an int, which is the size. Yeah, that makes sense. So I will still need to have a type conversion function then. I will still need to have that. Okay. Okay. So that means for the enum type, the int is all I need. For a struct type, the only thing I need is I need the base name and I need a list of type. And for a function type, I'm probably gonna keep what I had. Oh, what am I doing this in this buffer? Which was list of type for the arguments and maybe type for the return type. Excuse me. Unused import, that's always a good news. That means everything that's compiled in this module. Oh, what's lowering collection? Oh, yes, I remember that. I remember that. I'm just gonna make one change. Collect M is gonna become collect, or collection, in fact. I will need one other thing here, since this is now a monad diagnosis. I will need some form of I have those functions here. I'm gonna copy into here. But this implies having a location, which means I will need to keep track of the location. And do I have a name? Does my interface contain? It does not. Excuse me. So I'm gonna need to add the location, which is gonna be a location which is gonna be used for the few areas that are gonna be used in this. And I'm probably gonna need lowering info. Which is gonna be everything we need to know about the current context, which is gonna be the interface. And the declaration name, which is gonna be a base name. So that's gonna be a lowering info. So here we can get the declaration name by doing a view of the declared name. And use, this is gonna be use the ls location, use the ls location, and everything else is gonna be the same. Okay. So that means, however, that now run lowering here. I need to put a default location in this, since there is a location in the state, so the state needs to be initialized with a location. So I'll have to figure out a location for this. Maybe I'll give it as an argument. Because this is also going to require a base name, which is going to be the declaration name, which is going to go into the lowering info alongside the interface. I'm tempted to change. Do all of the error messages need the location? I suppose I could just start with this. If I have the module name, I can make a default location, initial location. But I need the file path, not the module name. That's annoying. Okay, so I'll need some kind of location then. That, or I do nothing here. And this is a maybe location. And here I do an internal compiler error if I have. I'm just gonna do a from just for now. Assuming therefore that the location will have been updated accordingly. And the location will be updated with statement. Where are you? Here, process statement is actually a with location. And so here we can say that the current location is the current location. And then this becomes a case of the located thing. There we go. What am I missing? This becomes a traverse with key, I think. Because I need the base name. Oh, this is the actual name. That's fine. So that means here I have the actual name. I have the actual name, and getting the base name will be just a matter of deconstructing this name and giving it here as the name base. Okay, the issue with this is I'm looking at symbols that have been already validated. So I'm looking at symbols that are the concrete instantiated version, but I'm reporting errors that point to the original declaration. That's fine. Okay. What am I missing? Oop. Base name not in scope. I need to import representation name. Location in scope. I need location. Declaration name is not something that is in scope. That is correct. This is called lowering thing decla name. Ah, it's not called that. How is it called then? No, that's how it's called. Unless I have forgotten to do, I have forgotten to do the lenses. That's why. Okay, okay, okay. I'm gonna do this properly. this becomes current location. This becomes current location. And we didn't do the horrible partial from just. There we go. Next. Oh, because I'm forgetting the last argument here. There we go. Defined but not used. We like those errors. Wait. No, it's fine. Those are actually... I don't need to export declan name nor ls location. I just need to export Warren and fatal. When that diagnosis not in scope, it comes from diagnosis. IR. Huh. Am I quiet? Is the sound not being picked up by the That's weird. I've moved the microphone a tiny bit just to avoid saturating it, as I sometimes do. Let me know if if it continues to be weird. Wait, so why is IR not in scope? Did I forget? Oh, did they remove it? I might have removed it by mistake. Huh, weird. I'm looking at the like volume bar in OBS and it seems to be roughly where it usually is. Maybe Twitch is doing something weird. Would not be the first time. So here is what I had forgotten. I need to leave this in. I think it's fine. Yeah, I don't know. Maybe it's just I have the microphone further away than usual. Let's try that and see if that makes a difference. Okay, that's an AST function. No, that's an IR function type. Ah, this is where everything gets broken. I have changed the IR type, so all of this goes away. I will need to salvage a function I have deleted called translate type. Except it has nothing to do with how things are now. I might just rewrite it from scratch. So translate type will be a function that takes a concrete type of the AST. I haven't uploaded yet. Actually, let me do that quickly. So first, I have added the range set thing and day 5. So that's 2025. I can't type, I'm sorry. Haskell day 5. And then I've added day 5 at the type level. And it is now pushed to the repo. So translate type will take a type from the concrete type from the AST and return a type of the IR. And that is just a big old case. I suppose this is a maybe type, and I can therefore also salvage force type. Where are you, force type? Which was the one that was doing a... there we go, that's the one. Interesting. Translate type seemed to have been in the monad. Why would I do that? Oh, because I needed to look things up, and now I don't need to anymore. Therefore, this becomes a lot easier. Force type is not in the monad. Ah, annoying. So this is not a path, this is a concrete type. Concrete type here, and finally show concrete type here. So let's copy the one from the AST, validated. That's this one. So that's a case of this thing. So if we encounter any of those are pretty straightforward. Those are just their IR correspondent. Those are nothing. There is no type for those here. For an enum with the base type and a list of possible values, that is an enum type in the IR with the length of the values for now and nothing else. And here, if I have a struct type info, what do I do with it? And here I have a function type info. What do I do with it? In the IR, the function type info, I need the argument types and then the return. So if I look at the function type info, this will be this thing. Excuse me. So I'll copy this to have it in scope here. It's the downside of coding at this resolution. I have so little context visible. So here I will be returning a function type where I have first Oh, I will need to do a monadic thing in maybe, I suppose. So the arguments will be a traverse. Hmm, not exactly a traverse. I mean, it will be a traverse translate type, that's for sure, of, I guess I can do it, yes, traverse translate type of a bunch of operations on the function arguments, and those operations are gonna be map. Well, might as well do it separately then. Well, no, I don't need the map if I do it there. That's the second thing in the tuple, and that's the function arg type, which comes from the AST. And the result is in the maybe monad, so that's fine. And now I can return, and the return is also a translate type. Well, a traverse. Oh no, the traverse. There's no need of the. Oh, I need to be careful. It's not in the maybe monad. It's fine for it to fail. It's fine for a function to return unit. So this is a function type of the arguments and translate type of the fun return. For a struct type info, what do I have here? I will need the base name, which is the struct base name, and I will need the type arguments. So let's look at the struct type info. It's not here. It is here. So I will need to do a params is going to be a traverse of translate type of the struct type params. And the result will be, and it's a pure here as well, an IR struct type with the struct base name and the parameters. Okay. So there's a few places where I'm gonna need to add this force type or translate type. Function archetype is defined. Actually, I suppose I could re-export. I do export common. Okay. So if I export common, then that just means I have made a mistake. And it's not function, it's function archetype. So wait, validated re-exports common. Oh, I don't import it from common. Okay. I will therefore need to add function archetype to the list of imports. There we go. Oh, I suppose struct info has to be a concrete functor. Can I make it so that It's already the case. Okay. It's not necessarily qualified, so I don't have to qualify types that are clearly from one side or the other. Traverse with key is not in scope because it's an M traverse with key. That's because the interface comes first. I've just noticed that there's a typo in the variable name in this function. It's consistent, so it's not a problem, but still, let's fix it. So here is a case where I need to do a force type to convert an AST type into an IR type. Except I'm doing it at the wrong scope. It needs to be done here. This is LS location, not VS location. I did solve part 2, yes. In my normal version, I did it with like this merge of ranges. For the type level, yeah, I just expand everything. However, I did not test my type level solution on the actual input because since I'm doing it with purely piano numbers, no extension to the language, um, no data kinds, no numerals lifted to the type level, no type level operators, none of this. It means that if I wanted to test with the actual input that has like values in the millions, I would need to create a million types like this to have n with like n digits or so, like 9 digits or something. And the compiler doesn't really like creating millions of type aliases. It doesn't like that. So I haven't actually tried on my actual input. I would need, if I wanted to try on my actual input, I would need to change this to make use of some of the features of the language, like type level numerals and stuff, rather than using those piano numbers like pure horrible type thing. I did it this way because I think it's more fun to like there is not a single like extension beyond type families. It's purely type data type and type family and nothing else. But as a result, I am only running on the example, not on my actual input. But yes, for part 2, the way I do part 2 is I expand every range. Like my recursion on part 2 is indeed inserting all of the things into a set, and the things I'm inserting is enumerating all of values in the range. So it is, I mean, it's fast on the small example, but it's not very elegant. Excuse me. Then wait, ls location is also wrong. Oh, is it because I have forgotten to export it out of this? Possibly. Yep, that's what it is. I'm starting to feel sick. I should probably not stay much longer. Aha, indeed, the let info is no longer the same in the AST. So this is let value. In fairness, like thinking about performance in Haskell is not like you how do I phrase this? Imperative languages like to claim that their performance model is more intuitive, and that is often true. And it is fair to say that like Haskell performance can be a bit tricky to reason about. I think one of the biggest hurdles is the fact that it's actually garbage collected, which is very annoying as well. But there are some pretty decent performance, like what's the word? Profiling tools in the language. You can do a lot of work in terms of performance, but it requires shifting the way you think about the language for sure. I was looking at what was I looking at? Process L value expression doesn't exist. Yes, that is true. Laziness is definitely something that can trip people. That is absolutely true. Oh, here I already do. Okay. Wait, I do the process L value expression here. What do I do in compound? Oh, here I do force L value expression. Okay. Yeah, this will have to be a force as well. Although, yes, tentatively, I'm going to use process in case I can do this without having to do a report ice. Yes, okay. Yeah, so the thing with lazy evaluation is that the set, like in terms of extremely low hanging fruit in terms of performance, is to enable an extension called strict data, which makes basically all of the fields of all the records in your code strict by default. So it's basically the same thing as if I go to this thing here, the fact that I have this extension enabled would be the equivalent of me saying this manually if I had the extension enabled to put this. Like I am making all of those field strict by default. And there's another extension which is now part of the language for like recent versions of Haskell, where if you have a strict field in a record like this in a data type, and it is small enough, it gets unboxed automatically for you. Which means compared to like naive Haskell 99, where if this is an int and an int, you would have a pointer for each and they would both be lazy, you'd have a thunk. This with those extensions enabled because becomes an unpacked int. Usually the way like having the enabling this extension means your types are not lazy, so they are whenever you create a struct a record, it is evaluated, but your functions remain lazy in their arguments, and this compromise is pretty good usually. You do not lose the ability to manipulate lazy structures that you can do in the rest of Haskell, but in terms of performance gain, it is such a much better default. So that's a very like accessible, low hanging fruit. The second biggest low hanging fruit is not using single linked list. And I do use still linked list absolutely everywhere, but there's a lot of places where I should just replace them with sequences or arrays or vectors, because that's a place where I would save a lot of performance as well. Yes, process L value expression doesn't exist yet. Oh, what did I change? Oh, yes, that. Okay. So process L value expression will be a variant of this. And it should always give me a register. And that is a typed value. And I'm doing a case of the typed value within of. And in my validated representation, An L value expression is one of those. And for now, I think I'm not gonna care about field access expression and index expression. So for now, those are undefined, well, unimplemented. And for those, I have the variable name. And those become the same thing that they are here, just that, basically. Yeah, you absolutely. I mean, starting with list in Haskell is always a good place to start because lists, while being bad single linked lists, are everywhere in Haskell, and as long as you don't try to like do long ones and you only use them for like iterating over basic things, they work pretty well. The compiler has a lot of optimizations for them. There's like a lot of like list fusion optimizations in the compiler. Starting with list, pretty good. It gives you a very good intuition for how things work in Haskell. The second you want to care about performance, you ditch lists immediately. And yeah, sequence is a very good one to go to by default. It uses finger trees underneath as an implementation, which means we can also like append stuff at the end without having to traverse the entire thing linearly. Vector is very good, and also vector is a good way to learn about the st monad and like thread safe references and mutability in Haskell. So yeah, that's there's this is a good thing to look into after you're getting used to list. But starting with list, never a bad idea. What am I missing? Not in scope name, because it's called function name. I should have two arguments, but has been given three. Here, this is the struct type that I don't care about. Here, I will need to do a translate type, a force type, actually, of the type info, which I'm going to copy because this is something that's going to come back quite a lot, I assume. Excuse me. Let's see, what do I do for a normal assignment in this? Oh, I already have the, okay. Okay. This is also becoming force type of team. Compound assign needs to be changed. Something here makes this believe that this should be an expression, while in fact it is not. Because Oh, is it because I've made a mistake in the type of L value? Yes, that is an L value expression here. Wait. Oh, I suppose. I think that's inaccurate. Oh, wait, unless assign register does the... Oh, no, assign register. Okay. Okay, okay. Thank you for tuning in. And yeah, I usually stream. My regular streaming schedule during the year is, well, this year has been Tuesday and Thursdays. For the Advent of Code, I'm doing a bit more. I'll be back on Monday to continue the Advent of Code. I'll probably stream every weekday next week if I can. But yeah, thank you for tuning in. This is yet again. I need to force the type to convert this thing from an AST type into an IR type. What is wrong now? Oh, yes. Now there's no longer any maybe. Wait. Aha. There we go. This is a traverse register of not a force type, but a translate type, since it is okay for a function type to be unit and or panic or void, and therefore it's okay for this to be a maybe. And this is going to be the same thing here. Traverse the register of translate type of the return thing. It is getting late. I'm not sure I'm going to make this compile today. Yes, okay. That's why I did it this way. I need the function type info here for the... Oh, I don't actually. No, I didn't, because I need to get the IR type. So that's going to be the function type. That is a translate type, well, a force type, in fact, of force type of a AST function type of the function type info. And then here, that is this function type. But that means here I need to extract the function return out of the function type info, which I might do with yet another $sign. Force name, I suppose, then? Aha. Force name is not in scope. So I have resolve... Well, wait, no. Resolve name is perfectly fine. So what they changed that... What made me think this was required? Oh, expected maybe register and actually got a real one. So this is the other way around. I just need to put just into the thing. That's definitely an easier problem to have. Ah, of course, and this is a force type of the type info. To the point that I'm tempted to actually introduce an alias for this since I'm doing it everywhere anyway. It's fine. As I was saying, force type info. Oh, those are the range expression nowadays, and that's a range expression with something that's unimplemented. I don't support dynamically sized types yet. So assign register expect. Oh, it is expects a typed L value expression. Wait. So do I need to do this process L value expression then? Oh, I do, but however, I need to here give the left hand side. Yes, because I need to get the register that is used for the instruction, and then I assign back into the LHS. There we go. This is a force type. So is this. Okay. Oh, somehow, no, this is still in the monad, so something is wrong here. Oh, this no longer needs to be in the monad at all. That's what. Because now I already have all of the information in scope. What do you mean by this? So if you're asking about the do thing that I am doing here, like foo equals do stuff with like A, B, C, that's not a vector. At least not usually. Or do you mean the actual vector type? This one. Um, well, it seems that vector does have a monad instance, so it might be possible to do that, in fact. Interestingly. That's fascinating. I never realized they had that. Wait, I'm an idiot. No, of course it does. But it is not the same. It's not enumerating the thing. It is akin more to a list. Let me show you for list actually, because lists are monad. So of course vectors are monad. What am I saying? But a do block in a list is akin to a list comprehension. For instance, if I do this list comprehension where I do x plus y for x in each of 1 to 4 and y in each of 1 to 4. That gives me this list there. The Python version of this would be x plus y for x in yada 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 for y in yada yada yada. That would be the Python version. And so that is the least comprehension syntax. But the thing is, the least comprehension syntax of list happens to be very similar to the do block in the list monad. So you could rewrite this same thing as my list here is open a do block for each x in 1 to 4, for each y in 1 to 4, and a thing in the list monad must return a list. So this must be a list here with perhaps one element, like something like this. But you can also do it with a pure like this. And the result of this is exactly the same. And that's because the monadic operation, the bind in the list, is a concat map, basically. So this is equivalent again as doing for a concat map into takes an x that returns 1 to 4 concat map into something that takes a y and returns x plus y. Except concat map doesn't exist. That is the monadic bind. So that's what a do block is in lists. It is similar to a list comprehension in a sense. It is the sequential concat map thing in the list monad, and I assume that vector is the same, given that that would be a pretty reasonable. I don't have it in this GHCI, but I suppose it would be the same thing. That would make sense. And in fact, if we look at the code, pure would be putting just one value in the vector, and bind is flip concat map. So yeah. So if you had somehow, I can't do it here because I don't have the module in scope at the moment, but if you had v1 that is some vector of int and you had v2 that is some vector of int, you could absolutely do v3 is a vector of int obtained by doing do for each value x in your vector v1, for each value y in your vector v2, pure x times y or whatever. Which here, of course, is not going to work very well since, undefined, but you get the gist. Yes, and I don't think you could make something like that makes sense. I don't think you could manage to make a do block that for which like 1, 2, 3, 4 is something that's meaningful. Because for that to be true, you would need to have. Okay, I'm weighing the pros and cons of do I try to showcase an implementation where that works versus the con of actually this is not using the type classes the way they are intended, and therefore this is probably a bad Haskell lesson in a sense. Because you could probably use num, the type class, to make something from integer so that 1, 2, 3, 4 are interpreted in something that makes sense in your context. Wait. If I did, for instance, let's say, I'm gonna call it vector since it's not in scope, but vector of A is just a vector of list of A, deriving show functor applicative monad. And instance num of v of a, if num of a, where from integer is v of pure of from integer. And now with that done, I can do something horrible like do 1, 2, 3, 4, which I'm gonna say explicitly is a v of int. And that just gives me the last value, however. Like everything else is ignored. But that is technically something that is the syntax you were asking for, but in not the right way, no. Although, could I make it so that this creates a vector 1, 2, 3, 4? It would still be wrong. I could probably do that. What is the monad what is monad again for function? No, I don't remember. There is of course, this would be with something like that. Yes, okay. So function from int. No, that wouldn't work. There might be a way, but yeah, again, this is not what a do block is for. Yeah, a tiny bit. I'll try to think about it. It might be possible to use. So the trick I'm using here is I'm using the num instance, which has like, okay, this thing is a number. And some of it is from integer, which is like, okay, we have an integer literal. We can create a value of this type. So here I'm saying that like this vector of numbers is actually a number. And if we find a int literal that just creates a vector of size 1 of that value, which is a bad use of the num class, and now it's how it's supposed to be used. And then I was using the fact that this is a monad, so this in this context where everything is a vector is interpreted using the from integer thing, and therefore this is syntactically valid even if it's meaningless. And now I was thinking of, can I use from integer on even more complicated things, such as function from int to something, because that is a monad as well. So I could probably make some kind of like function composition composing those things, and therefore making this give me a function that creates a vector. But no, I don't think I can do that easily, and I think this is too far into the nut snipe. So let's go back to this, because it is getting late and I want to try to see if I can make this compile before I stop for the evening. Retrieve field info. Oh, it needs the index as well as the type, so I've messed up. No, wait. Oh, it's just that this is no longer monadic at all. So it doesn't need to be in the monad. Perfect. Yes, that seems. Oh, that's just because the struct info is no longer required. I have it as an argument. There we go. Which means the struct info is not required here either. It's not required here either. Okay. What is wrong there? Aha, of course. Here I'm expecting this to be a type, so here I need a force type again. Converting my AST type into my IR type. Ooh, we are at the point where... Oh, I don't use the function type info at all? Yes, I don't need the function type info at all for this thing. Okay. Oh, hell yeah. That compiles. Which means I can go back to my main, my temporary main. And I had some code there. Okay. I can do now the lowering into IR of the module we have compiled. So if I have I suppose I can add another thing to my state here, which is going to be the IR for the... It's going to be the IR for all the modules I have compiled, which I guess I'll put here, which means here I need to put something, and the IR is obtained by doing lower module, which takes an entire interface and gives me an IR. So I'll get that right here. The IR is going to be lower module of the interface. And here, so this is going to be the IRs plural. The IRs are going to be modified. Was going to be an insert of module name and the new IR in the IRs. Which means at the end of this, I'll have the IRs here as well. And I can add a print there. Which for each, which I guess, actually no, I will want to do I want to do that to have just one big hash map, I think, of all the symbols. Okay, so this is a render name, and then this is print. I'm just gonna try to print the IR, we'll see what happens. Oh, except I had those functions here, I'm just gonna use them. So this is a traverse with key of print function of the things in the IR, and that's this function. Okay. Or maybe I just don't do that. It's fine. Let's try to see if this compiles. If it compiles, then I have restored, unless it, of course, doesn't work. But I'm at the point where I might have restored Traverse with key. Wait. What? Oh yeah, it's defined but not exported. I will need the IR in scope. I want to believe. Oh, come on. Um, hiding for. Okay. Now, let's try moment of truth. The lowering into IR worked. That is, well, worked. Did output something, which is nice. So let's look at an example of something a bit interesting. All of those functions are boring as all hell. Did I have some interesting stuff? Oh. In my absolutely horribly named folders. This one doesn't compile, that was on purpose. Okay. Let's go back to this one, since I have nothing useful here at the moment. Let's remove it. So, for how the backend decides, the way this works is each function is like a list of instructions like this. The size of an instruction doesn't matter. It only matters for one of the instructions, which is push, which is like when you go from this instruction to this instruction, the size of this block in pixels determines what value gets pushed to the stack. For every other um, trans- like transition of colors, the size of the region doesn't matter. So I'm only using like I think 4 wide for my functions because that's more than enough. The only thing is, if I want to push like 1 million on the stack, I'm not pushing like 1 million divided by 4 and all that lines. I'm doing some like divided by 2 by power of 4 kind of thing. When I add some value, multiply by 4, add some value, multiply by 4, and so on. But otherwise, like the size of a block doesn't really matter. So I here this is just like 1 pixel per instruction basically. Okay, so let's make an interesting function to see what happens. So I will want to give it, I'm gonna get foo, I'm gonna give it an int, an x which is an int, and y which is an int, and make it return an int or something, just to see what happens. Let's do something such as if x is 0 and y is 0, return 0. Or maybe I do an or here. There we go. So now I know they're both non-zero. And I can do, because I want to test the... I do actually do that. I do that here, like you see, like the black borders here are things that the interpreter cannot cross, but those pixels here are not, and this one is open here. What I do here is basically this thing is like I have like an address system for like jumping function call and return from functions. And this strip is like trying to figure out like where do we jump in the program, and the linking thing is assigning to each label in every function a unique integer address. And when we decide, oh, this is the right entrance for this function, this thing makes the interpreter rotate 90 degrees. So we cross through this, and those things make the interpreter rotate and set the stack correctly for the beginning of the function. And then here it rotates 90 degrees and crosses through this block of color. But since it's going from white to this to white, this block of color does nothing and is not considered an instruction. And then it starts doing things here. The same thing here is true for the entrance, and so on. So you can make the same region do different things depending on in which way you actually go through. I am only using it for like crossing through crossing through the instructions. So here I'm testing both a non-trivial expression and branching. And what do I want to do here? I'll probably want to do a loop. So while x greater than 0, y plus equal x, x minus equal 1, something like this, return y, which is a complex enough function that it becomes interesting. Okay, so it did compile. If I go see this thing, now I am looking at the debug view for this one file and therefore this one function. So there has been no simplification in scope. X is indeed this one all the way. There's nothing very interesting happening here. However, the IR that we have generated, this symbol foo, this is a unique name that the linker will work against, starts at the label 0. It has two arguments, I0, I1, two integer registers. We assign I2 0. We compare an equal B3. We compare I0 to I2, okay, which is the 0 literal, and we put the result in B3. We do a branch with a target, which is the label 3 with B3 and I, or the label 2 with 0 arguments using the B3 thing, where I think this label 3 is the right-hand side of the Boolean AND, where we do an other branch to decide where we're going with this, I think. Oh, no, I think... Let me just remind myself which way around branch works in the IR. I don't think it's documented there. So let's have a look at the lowering. When I do a if, so a if branch is the if block, the else block, and the register. Okay, so if the register is non-zero, this is the non-zero case first, the 0 case second, which means that for a OR expression like we have, a Boolean OR, where is the expression? There we go. The first branch is the resume label, so we skip past the thing, and the second, because if it's an OR and the first is true, if that's an OR, the first is true, of course we skip, we don't need to evaluate the second one, and therefore the second label is the right-hand side of the Boolean OR. So here branch on B3, which is the comparison of I0, our argument, to I2, a register that contains the constant 0. If that is true, we branch to label 3. If it's false, we branch to label 2. Label 3 is the end of our it's the end of our Boolean or, and that's the case where it's true, I think. And the label 2 is the other one. We do an assign 0 into I4, we compare I1 to I4, and we put the result in B5, and we jump to the end of our OR thing by giving an argument which is B5. So here we always finish with this argument, the register B6, that contains the result of the OR, and that is itself a branch because it was an if, where based on the result of the OR, we jump to 4 if it is true, or to 1 if it is false. 4 is the body of the if, where we just do assign 0 to the register I7, and we return out of the function with this register. And otherwise, in this thing, we jump to 1, which is here, which is the rest of our code, where we jump directly. So label 1 is immediately a jump into label 5. Oh, didn't I have some simplification code for this? I think I do. And label 5 do some comparison, which will be comparison and then do a branch. So that's our while loop. And if the comparison is false, we jump to label 7, which is our return, the end of our function. Otherwise, if it is true, we jump to 6, which is the body of the while, where we do to add together into a new register. We assign 1 to a new register. We subtract the thing, and we jump back. Oh, is that correct? Is that correct? I don't think that's correct. The return here should have... Oh no, we always branch from this one. Okay, so yes, this is the value of y that is taken as an argument by this block, because the value of y will have changed. Wait, the value of x will have changed as well. Something is broken here. This doesn't work. Because this should be taking the value of x and y as arguments for this. Yeah, here is an argument that is not being used in the block. So something is broken here. Okay. Because this block should be taking both the values. Wait, unless no, jump to label 5, yeah, with E16. That is completely wrong. What is E16? Where are you coming from? I16, you are... Oh no, you're actually coming from here, which is the name of this argument. No, okay, this is completely wrong. Okay, so it is not far from correct, but it is not correct. So we will have to fix that next time. And also, I just want to have a quick look. I thought I had... I don't do this run collect at all, which I used to do before. If I do a git diff with dev of the main, was I doing this collect thing? No, I was not doing it. So wait, I have this entire thing there. That is just entirely unused, it seems. Oh wait, collect blocks. No, okay, it's called. Perfect. So this is used. Okay, but it's still wrong. Sadly, the the IR that's generated here starts correct and then gets completely wrong, which I assume is due to the changes we've made to the variable resolution. That being said, the return not taking an argument makes sense. There's only one register that will contain. Hello. Oh, hello everyone. You're arriving just as I'm about to stop. That's fun timing. I am debugging. I've just finished cleaning an old piece of code after a long refactor. Oh, the advent of code has. I've been streaming for 5.5 hours, and only 1 hour of this was the advent of code. Because today's problem was fairly easy. The main thing was I defined a range set, which is a set of ranges that guarantees that there's no overlap within the ranges. And the trick is to basically, when inserting a new range into the set of ranges, trying to find the overlap and merging the sets as we go, basically. Which, while after I had done that, that made day 5 uh, extremely straightforward. Like, for part 1, it is for each ingredient, is it within the range set? For part 2, it is getting the list of ranges, getting their size, and doing the sum. So that was not too complicated. The fun part was I did, as a fun bit, solve day 5 at the type level. So no, not value level, purely type level, using piano numbers where there's a type 0, there's a type successor of n, and that's how it's used to create numbers. And then a bunch of type families to do type association that mimics computation. And only running on the example input, because I didn't want to create those type level lists for my actual input, running the solution at the type level, which is fun. It implies using like list type level lists as sets. But yeah, it was fun. And I'm back here now to my compiler project. And I've just cleaned an old piece of code that does the lowering into IR. Thank you for tuning in. And yeah, your timing is absolutely fine. It's just that I've been at this for 5 hours and a half, so it's time to take a break soon. But yeah, I was cleaning some old code for the lowering into IR of this compiler. And this is the function I'm currently testing with. That looks a bit like Rust. And I have some bugs in my IR lowering where the IR that this generates has a few bugs. Namely, register allocation is doing some shitty stuff here. This is the body of the while, and it jumps back to the condition here, but it's only jumping back with I12, which is the result of the addition of something into y, but the fact that x has been changed is not taken into account and not given as an argument to this block, which means that this block is always only comparing I8, the original version of x, which is wrong. Despite the fact that this, like the code knows that this x here is the same as this x here. So something is wrong. I'm going to have to debug the lowering into AR. I'm tempted to have a very quick look to see what's wrong. Because this is probably just a matter of... This is probably just a matter of... When I do resolve name there, so I am in a return statement, which is, where is statement? It's up there somewhere. I'm in a return statement. I look at the register in which the result will be, and then I return that register value, which means that, this might be where this is wrong. Here I look at the, I realize that this expression in the return is a local variable expression with this variable name, and I just resolve the name. But resolve name should be doing oh, so I look at the current block. And since there is no declaration of y in this block, I need to look one up. The parent of block 7 is block 5, because it's the only one that points to it. Therefore, there must be something in label 5 that assigns to y. So that is a problem, that is a bug with the multiple assignment and the sealing of blocks. Wait, no. Wait, is it actually correct? No, it's not. It's not. I think what's happening here is this y here isn't in this block, the block 7, so it goes to look for it in 5. It's not assigned in 5, which means 5 has to... So 5 has to make it an argument, a block argument. Which is why it is here as I15. And it has to then register block argument. This will traverse the parents to fix this. So since now block 5 requires the y variable to be given as an argument, block 6 will give it properly, which is because it's the parent. And the other parent of label 5, which is the label 1, block 1, will also be giving it, which is the I16. And I16 must be coming from since there's only one parent, it doesn't need to be an argument. It just needs to be declared before. And it was because the parent of label 5 is label... Sorry, of label 1 is label 3, in which I16 is defined. Okay. So for Y, it's okay. For X, however, something is wrong. I think that's because when I do the lowering into IR, this X here is in a block, the condition block that has two parents, but that is not sealed yet. So I have something about the resolution of sealed blocks that is wrong. Okay, I'll fix this next time because I've been at it for too long. On Monday, I'll start with the advent of code of this weekend and on Monday. And if I have some time, I'll go and debug this. In the meantime, thank you everyone for tuning in. That was fun. I'll try to upload. I need to figure out a way to split my streams between Advent of Code and compiler. The YouTube editor is terrible, so I might just do it with DaVinci Resolve on my machine. I'll figure that out. By next time, this will be done. In the meantime, thank you again, everyone, for tuning in. Have a good weekend, and I'll see you on Monday.